Alright, I have continued my reading through Chapter 7 of Fire in California's Ecosystems. This chapter is going into the interactions that wildfire has with your soil, your water, and your air. And the beginning of this chapter has been specifically about wildfire's interactions with more of the physical properties of soil. So yesterday I talked about wildfire and soil temperature. I could do maybe just a quick refresher on that so you don't have to go back and listen to that whole episode. Basically, what it's talking about is that when you have a fire come through, it can heat up your soils. Now, most of the heat from your fire is going to go up because heat rises, but about 8 to 10% of that heat is going to go into your soils. And this could be a bad thing because it can kill your microorganisms, bacteria, fungi, can destroy some of the roots that are in your soil, your seed banks. So can have negative effects on the soil. It can also decrease the soil moisture because it can evaporate the water out of your soils. Now, that all sounds pretty bad, but there are some good things working in our favor in terms of soil and decreasing the amount that your soil temperature is going to rise as a fire comes through. And interestingly, your soil temperature is going to go up more in a less intense, slow-moving fire than in a more intense, fast-moving fire. Something about that slow-moving nature just allows more of that heat to penetrate the surface. But the two things that are working in our favor in terms of keeping our soil temperatures down are the facts that soil does have water and it's porous. So how that heat is going to transfer down throughout the soil is going to be through conduction. And conduction likes when your material is touching. You think about when the heat travels up a metal spoon or a metal pot that you have on the stove, that heat is going from one molecule to the next, and it's almost like the energy from one just transfers to the next, and that heat transfers and moves up your metal spoon or pot through conduction. But you can imagine that if there's space in between those molecules, like in a very porous soil, so one that has maybe more aggregation and less just very fine clay, it's going to be harder for that heat to travel down. And you can just see massive differences where you may have a lot of heat right on the surface, and then if you just go down maybe 15 centimeters, there's a massive decrease in the amount of heat that penetrates deeper levels of your soil. Partly because it's porous, makes conduction harder, and then also because you have moisture in your soils. So just like before combustion can occur on a plant, the fire has to use some of its energy to evaporate the moisture out of that plant. The same is true for soils. Before your soils can heat up more than 212 degrees Fahrenheit, the water has to be evaporated out of those soils. And water compared to soil, water takes more energy to heat up and cool down. It has a higher heat capacity. So that is going to absorb a lot of the heat from your fire and just keep your soils more moist. Now that would make you think that if it's very dry out and there hasn't been a lot of rainfall recently and you have dry soils, it would actually be easier for those soils to heat up. So that was soil temperature. We talked a lot about that yesterday. Now let's go into, soil structure, soil porosity, soil color, and water repellency. So soil structure, one interesting thing that there's almost a duality or a contrast of what fire can do to your soil structure. So by that I mean sand, silt, or clay. You can think of sand as your larger soil particles, clay as your very small soil particles. So on one hand, it says that fires can actually kind of fuse your clay particles together and almost turn them into silt or sand. So it can you think of the heat almost melting your clay together into larger particles. So that would be taking your very fine soil and making it more coarse. Now at the same time, fire can also kill a lot of the organic matter or some of the fungi that aggregate your soil together. So doing that same process where you go from a fine soil to a coarse soil. And then that can actually make your soil more fine because you kill the organic matter and the fungi that would be aggregating those soil particles together. So that doesn't really give us any good answers right there, because on one hand it says, oh, fire is going to make your soil more coarse, and then on the other hand it says, oh, it's going to make your soil more fine. But it seems like the larger impact on soil porosity is, and maybe, yeah, I think if I just keep talking about this, it'll make sense. The larger impact's going to be on that killing of the organic matter or your fungi that aggregate the soil together and make your finer soil. That can have impacts on erosion and things like flooding and infiltration of water into your soils. So if you have more coarse soil, you can imagine there's going to be more space in between those soil particles. So that's going to allow water to filter down into your soil more. Versus if you have very small soil particles, that's going to be a bit more compact, so it's going to be harder for water to get down into your soils, which means more of it is going to turn into runoff, which could potentially increase flooding there. But it's also going to increase erosion, because you can kind of picture this in your mind. If you have more coarse soil, you could think of that almost on a large scale like rocks. And maybe you have a stream and most of the rocks are just staying in place. But then if you have a very sandy, river bottom, more of that sand will be able to be picked up by the water and brought downstream. Now that's maybe not the best metaphor or analogy I could use, because the larger soil particles are your sand. But you can think of your sand almost as your rocks, where if more of your soil is aggregated together, less of it's going to be picked up by the water and be able to erode away. Versus if your organic matter or your fungi has been killed, so there's less soil aggregation, more clay, more of those small particles, when water comes through, it's going to be able to pick those up more and erode more of your soil. That was probably a way too wordy version of how I could have explained that, but hopefully that made sense right there. If that was a little confusing, we'll go into a nice easy one, which is soil color. So you have a fire come through, it burns some of your plants, it leaves an ash layer on the ground, and that ash is going to be black. And then some of that mixes into your soil as well. And what that's going to do is it's going to be able to absorb more heat from the sun. That makes sense if you've ever worn a black shirt while you're exercising on a hot day. My dad would always almost make fun of me if I was wearing a black shirt while playing tennis on a day where it's 90 degrees. He'd be like, why would you do that? If you wear a white shirt, you're going to be much cooler and you're not going to sweat as much, you're not going to get as tired, and you're going to be able to play better tennis or whatever sport we were playing. And anyone who's worn a black shirt while exercising on a hot day knows that it gets hotter than when you're wearing a white shirt. Same thing happens with your soil. If there's a lot of burning, a lot of ashes on your soil, that's going to be able to absorb more sunlight, and then that's going to increase your soil temperature. It's also going to help some of the moisture to be evaporated out of your soils. And where plants get a lot of their moisture is from the soil. So that could potentially lead to drier plants. So if you had a fire come through, black layer on the soil, more absorption of heat, higher soil temperatures, more evaporation of water out of your soil, drier soils, less moisture available for your plants, which means drier plants, which means more fire, which could mean more ash on your soils. So what I'm explaining there is a positive feedback loop, where more fire could actually lead to more fire. So I thought that was pretty interesting for soil color. That one's a bit more intuitive and easy to understand. The last one is maybe somewhere in between these two in terms of complexity, and that's water repellency. So the best way I could think about explaining this is there's some leaves out there where you can almost feel that they're water repellent. Or on a rainy day, you can see that there's droplets of water on the leaf, and then maybe they'll fall right off, or the droplets just stay on the leaf, but you can tell they're not being absorbed into the leaf. And that's because some of our plants have almost like a water repellent resin on them. And then what can happen is when a fire comes through, some of that resin, I don't know if that's the best word to describe it, but some of that water repellent material or resin can mix down into your soils and make your soils water repellent. And that can have impacts on things like water infiltration, erosion, flooding as well. Now, before I get into that, it does obviously depend on what plants you have in the area. Maybe some plants aren't going to have as much of this resin as others, so if they burn, it's not going to impact your soils as much as maybe, I'm trying to think of one plant that's very water repellent, but if that one burns and some of that resin mixes in your soil, obviously that soil is going to be more water repellent than where you don't have those plants. So that's going to lead to spatial complexity in that aspect based on the differences in plants, but there's also spatial complexity based on the differences in your soils. So earlier I was talking about how some of your soils can be coarser, aggregated, larger particles, or they can be finer, like your clays. So if there's a certain amount of water repellent resin that's mixing into your soil, it's going to be able to cover more of those soil particles in the coarse soil setup than in the very clay soil setup. And that all has to do with surface area to volume ratio. And I know this is probably going to be getting a bit too sciencey, but if you were coating the surface of maybe 1 cubic centimeter of soil and you have very fine particles, more of that particle is surface area. There's less porous air between those. So you're going to need a lot more of that water repellent resin to cover everything within that cubic centimeter. Whereas in a much coarser soil, less of what you have within that cubic centimeter is surface area. So it's not going to take as much of that water repellent resin to cover all of the soil particles within that cubic centimeter. That means there's going to be more water repellent resin left over to cover more soil, maybe deeper down, therefore making the coarse soils more water repellent. So the reason that's important is because you think a fire comes through, maybe it's in an area where you do have vegetation that has these water repellent resins, and then it's in coarse soils. That's going to make your soils water repellent. And then especially if there's a prolonged dry period, that's going to, you can almost think of it as like putting a tarp over your soil. So then when the next big rain comes in, less of that water is going to be able to infiltrate into your soil, which is obviously kind of what your soil wants. That's what your plants want. That's what the root systems want, more water within the soil that they can use to grow and thrive. So if it's very water repellent, more of that water is going to turn into runoff. It can lead to flooding and then potentially more erosion as well. So that was maybe a bit more complicated than it needed to be as well. But the basic takeaway there is that while there's a high degree of spatial complexity because there's lots of different factors, whether you're talking about vegetation cover, soil texture, maybe the soil temperature, maybe the fire temperature when it came through, there's going to be lots of variability here. But overall, you could have soils becoming more water repellent after a fire, which can lead to increased maybe erosion and flooding and decreased infiltration of water into your soils, especially after a prolonged dry period. So that was the basic, maybe not so basic as I wanted it to be, but that's the summary of the physical properties of soil and how that interacts with wildfire. The next section in this textbook is going to be the chemical properties of soil and how that interacts with wildfire. And then we're going to be getting into wildfire's interactions with water and with air. So if you want to learn more about that, you can stay tuned, and thanks for watching.